Students, am I audible?
Yes, sir. Good afternoon.
Yes, sir.
Very, very good afternoon. Just I'm starting within 2-3 minutes. Fine.
Sir.
Yes. Yes. Am I audible now? Clearly?
Yes, sir.
Yes, sir.
Okay, fine. I hope the screen is visible now. Last topic which we are going to discuss, and that is electromechanical energy conversion. Fine. So, electromechanical is a word where electrical plus mechanical energy will come into the picture. Fine. So we know that while converting electrical energy into mechanical energy or mechanical energy into electrical energy, we need a kind of motors. Fine. So here we are going to have a discussion on various motors used in electrical subjects. Fine. So I will use a word called electrical machine, where it is made up of a motor or a generator. Generator will generate the electricity, and the motor will have a kind of rotation of a rotor, or it will be a torque. So output is your torque, rotation, speed, and you can connect the mechanical load. So here we can connect the mechanical load, and here we can connect the electrical load. Yes. So this conversion from electrical to mechanical and mechanical to electrical is nothing but it is a mechanical energy conversion system. So here in generator, we know that mechanical energy is being converted into electrical energy, and in motor, that electrical energy which is given is being converted into mechanical energy. Okay, so let us discuss. As what I discussed, the similar kind of things are written here. What happened? Fine. Take place through a medium of electric or magnetic field or the conversion devices. And these devices are electrical motors. In other applications where you can find the force producing devices like motors, continuous energy conversion devices, fine. Transducer are also a kind of energy conversion system device. So continuously energy conversion is possible through various sources. Fine. Like solar, we are converting solar energy to electrical energy, then electrical energy into mechanical energy, wind energy, fine. Hydro energy. So all such kind of kinetic energy are being converted from one form of energy to another form of energy. Clear? So here motor and a generator, which we are going to discuss in detail about this topic. So here a generator and motor, you have studied about Fleming's right-hand rule. And here it is left hand rule. So whenever we discuss about the generator, the Fleming's right hand rule will come into the picture. And if we talk about the motor, Fleming's left hand rule will come into the picture. So in right hand rule, we know that there is a magnetic field. So the direction of magnetic field produced by two different poles, N and S. So the direction of magnetic field is decided by the four fingers, and the motion of the conductor, which can be placed and it cuts the magnetic flux, and an EMF is induced, that is called electricity generation. Fine. So that can be given with the help of second finger, and from that represent the motion of the conductor. Clear? And similarly in left hand rule, that can be reversed. So here in this case, we are providing rotation. And the best example is the dynamo you have seen about. So rotation and one magnetic field. And your output is electricity. Right? And here in this case, we are giving electricity as input to the motor, that is being converted into electromagnetic field, and then interaction of two different magnetic fields, again the torque is exerted in the motor. Fine. So mechanical input for generator, DC machine, and output is electrical. So here we need to give flux. Similarly in motor, what is the input? Input is electric input. The flux is given in DC machine, and your output is a mechanical. So this is a basic understanding of generator and motor. So in generator, whenever a conductor placed in a magnetic field, or whenever it cuts the magnetic flux, an EMF is induced according to law of electromagnetic inductions. Fine. So similar kind of thing happen with the generator and in the motor, that is reversed. So motor input is your electrical, and generator where the input is mechanical, and output is vice versa. Fine. Okay. So this is about motor and generator. Okay. Now energy balance. So energy balance is where there are certain losses occurred in both the machines, whether it is motor or whether it is generator. So losses occur, and these losses can be in the form of heat. Clear? So here, whenever we have 100% input, suppose 20% losses are there, then output is 80%. Clear? So here we can have an equation of 100 is equal to 80 plus 20. Clear? And similarly in motor, suppose if your electrical is 100%, if is 20%, then mechanical is 80%, then it could be electrical energy is equal to mechanical energy plus losses. Clear? And here in case of generator, the electrical energy plus losses is equal to mechanical energy. Clear? So this loss part, this losses may be either in the form of heat, are known as I square R losses. You have heard about this I square R losses. Fine. This is a power loss in the form of heat with respect to time, I square RT. Clear? So this can be energy balance in generator and motor. So you have to be remember that this formation of equation like mechanical energy is equal to electrical energy plus losses for generator, and mechanical energy plus losses is for motor. So you need to be taken care of about this energy balance equations. Any question till now?
No, sir.
Any question? Fine. Okay. Now let us see the classification of different motors. Fine. So there are certain machines sometimes there are some linear or static machines are there, and rotating machines are there. So rotating machines are of kind of generator and motor, as what already we discussed. Fine. Again, in generators are of two different types based on the supply. Here, DC supply is given to the DC generator, and AC supply is given to the AC generator. So again, generator are classified into AC generator and DC generator. And similarly, motors are also are of having two different types, as what we give as an input. Input to this motor is DC and input to this motor is AC. So according to the supply, the various electrical machines are classified here. Now, what is the output of a generator? DC generator is DC. Actually, there is a process inside that is AC conversion, but again being converted through commutator into DC. So your output is DC in this case. In this case, the output is AC generator. It is also known as alternator. And these alternators are our power generating devices, where in power station such kind of an AC generators are there. We generate the electricity and we are consuming this electricity to our place. Clear? So these are the various machines. Okay. So today we are going to discuss about DC machine, fine, which is a part of your syllabus. So construction and then their working and everything that we are going to see. Fine. So here in this diagram, first of all, you try to understand two main parts. That is, one is a stator and another is a rotor. Clear? And this is the base. This is the outer circle, outer surface. We can say it is yoke. It is also known as yoke. Yoke is the outer surface, and it is a protecting surface is also considered as yoke. Okay. So here there are four poles. This is pole 1, pole 2, pole 3, and pole 4. You can see here. So south pole is again connected to the north, north to south, south to north. So there are 4 pole machine, and here in this case we will discuss in detail about these various parts. So what are the different various parts? One is the outer surface, that is known as yoke. Fine. Then these are the poles. Then we are going to discuss about the rotor, is also known as armature. Clear? So we are going to discuss all these parts in detail. So let us see. Construction of this machine. Okay. So here I have discussed that this is the motor outer surface, or what we can say the protective surface, known as yoke. Then this yoke is fixed at the bottom with screw on a plate of wooden or a plate of iron. Clear? So that cannot be smooth surface. It could be a fixed where the friction is zero. Clear? Now this whole portion which is shown here, the whole portion that is a stator here, because in this part all things are stationary. It will not rotate. Outer cover will not rotate. Then here these are the poles. As I have seen that different poles are shown here. So this is N pole, this is S pole. So whenever the N and S poles are there, then there will be a magnetic field generated. And this magnetic field is steady because we are giving DC supply to this DC motor. And hence a stationary magnetic field is created between north and south pole. Clear? So here, how does this pole make? There are certain poles on which the winding is wound. So here you can see, here the winding is wound. Winding is wound like this on a pole. So this is a pole. This is another pole here. Clear? And the winding is wound surrounding this pole. Right? And this winding is known as field winding. Field winding. Clear? So stator poles, or also if we similar kind of way we can write that it is field poles. Stator field poles. Clear? So whenever we discuss about the stationary parts, then there would be a stator field poles and stator field winding. So it is a kind of solenoid where it is made up of iron material where the winding is wound. So here the similar kind of arrangement is done, and field poles, field winding. So here you can see field winding is written here, field winding is there. Clear? Okay. Now we will discuss in detail about these field poles and flux, field winding. Okay. Now what is the function of this field pole and field winding? That it generates or it creates some magnetic field, which is stationary magnetic field. Stationary magnetic. It is like N and S. Students, some construction work is going on nearby these premises. So little bit there is a noise. Fine, so kindly bear. So here a magnetic field is created in between two different opposite poles. Clear? So this is a rotor part. This is a rotor part. And this is a shaft here. So this shaft where ball bearings are there, and with the help of these ball bearings, it is free to rotate inside this magnetic field. Clear? Now let us see what is going to happen in this case. Okay. I have already discussed about the yoke. Fine. It is a hollow cylinder made up of cast iron for small machines and steel for medium machines. So here these are the dimensions: outer diameter, inner diameter, length. And this is the length, overall length of this yoke. This is the pole. Fine. अब ये पोल है, वहां पर वाइंडिंग को काउंट किया जाता है. कैसे? तो ये देखो, winding is wound on this pole, and this part is fixed to the yoke. Yoke साथ इसको बोल्ट से फिट किया जाता है. Is that clear? यहाँ पे clear फिट किया जाता है. So it would be fixed to the inner periphery of your yoke. Clear? And ये जो पोर्शन है नीचे का पोल है, उसके नीचे ऐसा पोर्शन है, दैट इज नोन एज पोल शू. पोल शू. सो पोल शू का फंक्शन क्या होता है? सो वॉट एवर द फ्लक्स, बिकॉज इफ द वाइंडिंग इज वाउंड, फ्लक्स विल बी जनरेटेड, एंड दिस फ्लक्स विल बी स्प्रेड इनटू द एयर गैप यूनिफॉर्मली. सो पोल शू का काम क्या है? वो जो फ्लक्स आपके एयर गैप में जाते हैं वो वहां पर उसको स्प्रेड करते हैं. यस
सर, आपकी स्क्रीन बहुत लैग हो रही है.
अच्छा, मतलब अभी तो स्क्रीन दिख रही है ना आप लोगों को? हेलो
सर दिख रही है, पर आप जो लिख रहे हो वो बहुत लेट आ रहा है सर.
might be due to some internet connectivity issues, but fine, I'll go a little slowly, not an issue. Clear? Just a minute, मैं एक बार फिर से ट्राई कर लेता हूँ. Is it okay now?
Yes, sir.
Is it okay?
Yes, sir.
यस सर, अभी सही है.
So might be yes. So this is pole. Fine. और पोल के नीचे ये जो शू लगाया है, that is pole shoe. तो पोल शू का काम है मैग्नेटिक फ्लक्स को स्प्रेड करना, फाइन। तो कंस्ट्रक्शन कैसे होता है जैसे मशीन का, तो आप देखिए जैसे ये आपका स्टेटर सॉरी रोटर हो गया, फाइन, ये रोटर हो गया आपका, उसके बीच में एक एयर गैप होता है, क्लियर। सो दिस इज एन एयर गैप, और इसके पास ये अभी ये आपका स्टेटर का पार्ट हो गया, दैट इज अ स्टेटर, ये ऐसे। सो इन बिटवीन देयर इज अ प्लेस कॉल्ड एयर गैप। एयर गैप क्यों मेंटेन किया जाता है, बिकॉज देयर इज नो एयर गैप देन देयर वुड बी डिफिकल्ट टू रोटेट फ्रीली, रोटर कैन नॉट बी रोटेट, राइट। सो ये एयर गैप यहाँ पे रखा जाता है। जैसे आपने देखा होगा जैसे हम एयर गैप डालते हैं मैग्नेटिक सर्किट में, राइट। सो दिस इज अ मैग्नेटिक सर्किट वेयर एयर गैप इज देयर एंड वी हैव स्टडीड अबाउट दिस एयर गैप, फाइन। सो यहाँ पे फ्रिंजिंग फ्लक्स वगैरह एंड क्रॉस सेक्शनलिटी यहाँ पे बढ़ जाता है। सो सच काइंड ऑफ थिंग्स वी हैव स्टडीड. But here, whatever the magnetic flux created through the stator, because in stator we are giving supply, and according to the supply, this poles will act as N and the opposite pole will act as S. So there will be a stationary magnetic field. So ये magnetic field यहाँ पे एक N pole हो गया, यहाँ पे S pole हो गया, fine in this case. So what happened in this case? The flux created through this stator part that will travel through this air gap and then it will link to the rotor winding, clear. तो ये जो पूरा प्रोसेस होता है उसके अंदर एयर गैप आती है बीच में, एंड ये एयर गैप जो है उसका फंक्शन क्या है कि रोटर को रोटेट फ्रीली करता है, एंड दूसरा वो जो फ्लक्स उसके अंदर पास होता है और वो फ्लक्स पास होने के बाद वो लिंक होता है कहाँ पर, जो कंडक्टर होता है रोटर पे वहां पे लिंक होता है। तो लिंक होने से वहां पे क्या होता है, either electrical energy will be generated, fine, or EMF is induced. कैसे होता है वो, that we will see, clear. So ये आपका पोल हो गया, fine. Just a minute, बेटा, something is wrong. Just a minute. So now here you can see this is Fleming's right hand rule for generator, right? And the directions are shown here. Similarly, this is the working principle of generator. So मैंने बोला ये जो यहाँ पर स्टेटर होता है ये वहां पे एन और एस पोल होता है, वो क्या करता है, मैग्नेटिक फील्ड जनरेट करता है, फाइन। मैग्नेटिक फील्ड विल बी जनरेटेड इन बिटवीन एंड दिस कॉइल, ये कॉइल कहां पर, आपके रोटर, रोटर जो होगा उसके ऊपर ये वाइंड बाउंड किया जाता है पूरा। सो यहाँ पर ये कॉइल, कॉइल मतलब एक कंडक्टर का एक टर्मिनल विच गोज इनसाइड, वो वाउंड होके दूसरा टर्मिनल उससे बाहर आता है। सो देयर आर टू डिफरेंट टर्मिनल्स S1 एंड S2 हियर। तो ये पूरा वायर जो होता है उसको एक राउंड सर्कल में रोटेट किया जाता है, दैट इज नथिंग बट इट इज वन कॉइल, clear. And we already studied about that how this EMF is generated inside. तो यहाँ पे जो EMF जनरेट होगा वो AC टाइप का होगा, and there are certain devices which are connected like commutator, which is going to be converted this generation of AC into DC, and outer side we can collect DC supply, clear. So this is a generation of this machine. Now working of DC motor. So in DC motor again we are providing a magnetic field थ्रू एन एंड एस पोल, फाइन। एंड ये जो कॉइल है, कॉइल के अंदर आप करंट फ्लो करेंगे, क्लियर। सो when a current carrying conductor is placed inside a magnetic field, a torque is exerted according to Faraday's law. Clear? So here this is the working of motor. Now we'll see, we have already seen this construction of stator. Now this is a yoke. Clear? You can see this is outer surface of the motor. So it provides the mechanical support. Fine. Okay. Then second part is pole core and pole shoe. Clear? Here in this presentation, you can see clear cut dimensions, or we can say the diagram, because so this is a yoke. We can say it is a stator. Clear? And इसके ऊपर ये स्क्रू से यहाँ पे ये पोल को फिक्स किया जाता है. So ये जो पोल होता है, पोल के अगल बगल में यहाँ पे वाइंडिंग को वाउंड किया जाता है. फाइन. सो इट इज काइंड ऑफ सोलेनॉइड, एंड यहाँ से फ्लक्स जनरेट होगा, वो फ्लक्स पूरे यहाँ पे एयर गैप में स्प्रेड. सो दिस इज द पोल शू. सो इट इज मेंशन्ड हियर पोल शू. देन दिस इज द लैमिनेटेड core. Stop. Just a minute. Now okay. Just a minute. I'm starting it with another PC. Not an issue. Clear? चलो अभी ये तो आपको स्लाइड दिख रही है ना, पोल शू एंड पोल.
यस सर. सर दिख तो रही, लेकिन सर
Okay,
लैग
fine.
हो रही है बाद में आपकी आवाज.
ओके. वो थोड़ा इंटरनेट का इशू लग रहा है मेरे को. फाइन. मैं अभी मेरा एक दूसरा पीसी है, उसको रिस्टार्ट करके अभी चेक कर लेता हूँ. क्लियर? चलो तब तक हम बातें करेंगे. ये तो ये पोल शू पोल कोर में कोई तकलीफ? आई थिंक इट इज क्लियर. क्लियर? ओके. नाउ फील्ड कॉइल्स. तो फील्ड कॉइल्स, तो ये जो मैंने आपको बताया, ये पोल आ गया आपका, पोल शू आ गया इधर, एंड ये आपके वाइंडिंग. तो ये वाइंडिंग ऐसे वाउंड किया जाता है उसके ऊपर, एंड दिस वाइंडिंग इज नोन एज फील्ड वाइंडिंग. फील्ड वाइंडिंग. क्लियर? तो फील्ड वाइंडिंग का काम क्या है? उसमें से करंट फ्लो होगा, एंड दिस करंट विल flow through this winding, and hence the pole becomes electromagnets. Clear? Just minute में एक लॉगिन कर रहा हूँ, उसके बाद अगर पॉसिबल है तो वहां से हम. And do not worry, I'll share this presentation with you people. Fine. So do not worry about it, because ultimately it will spend more time here. Okay. So this is field coil. नाउ आर्मेचर कोर. तो आपका जो रोटर वाला पार्ट मैंने बात किया, रोटर, रोटर. सो ये रोटर के ऊपर यहाँ पे ऐसे होते हैं, और वो स्लॉट के अंदर यहाँ पे वाइंडिंग को वाउंड किया जाता है लाइक दिस. क्लियर? सो देयर आर टू डिफरेंट टाइप्स ऑफ वाइंडिंग. वन इज स्टेटर वाइंडिंग, which is known as field winding, and another is a rotor winding, also known as armature winding. Getting my point? So stator winding is known as field winding. आर्मेचर, सो ये जो रोटर वाला पार्ट है उसको हम रोटर भी बोलते हैं, उसको आर्मेचर भी बोलते हैं. क्लियर? तो यहाँ पे देखो आप, शाफ्ट, यहाँ पे शाफ्ट और की वे होता है जहाँ पे शाफ्ट को फिक्स किया जाता है. सो ये शाफ्ट वाला पोर्शन आ गया, एंड यहाँ पे बॉल बेरिंग पे शाफ्ट पूरा. सो दिस होल आर्मेचर इज फ्री टू रोटेट विद द हेल्प ऑफ बॉल बेरिंग्स. क्लियर? सो दिस इज आर्मेचर कोर. उसको कोर बोला जाता है बिकॉज अल्टीमेटली here also this core is made up of iron material. and the winding is wound on this for again generating some electricity. Clear? This is the commutator. So commutator कहाँ पे लगाया होता है? तो ये आपका जो रोटर हो गया, रोटर वाला पार्ट, ये शाफ्ट, ये रोटर, and commutator is also attached to this part. So ये जो वाइंडिंग आता है, तो एक वाइंडिंग यहाँ से ऐसे वाइंडिंग हो गया और ये वाइंडिंग यहाँ फिक्स किया जाता है. So this is known as commutator. कम्यूटेटर. और ये कम्यूटेटर कहाँ पे होता है? जो रोटर पार्ट होता है आपका, उसके पास में यहाँ पर लगाया जाता है. Now what is the function of this commutator? Because whatever the EMF is induced in the rotor winding, EMF is induced in the rotor winding or armature winding, is always in alternating in nature, alternating quantities, alternating current. Fine. So the function of this commutator is to convert the induced EMF, AC induced EMF into DC. So rectification का काम करता है ये commutator इधर. And the supply is taken from this commutator as a DC output supply, DC supply, or we can say DC output, because this is a generator. In case of generator, we are giving a supply to the rotor circuitry. No, we are giving supply to the stator circuitry. So stator को हम देते हैं क्या? DC. वो क्या करेगा? दो पोल जो है वो N और S क्रिएट करेगा, एक मैग्नेटिक फील्ड क्रिएट करेगा. देन बाय मीन्स ऑफ सम मैकेनिकल मूवमेंट, प्राइम मूवर, वी रोटेट दिस rotor in a particular direction, and hence the EMF is induced in the rotor, and this rotor induced EMF is in AC in nature and would be converted through this commutator which is connected to this rotor, and AC supply, DC is taken as output. Clear? So here this is a DC generator. In case of motor, we are giving supply to the rotor, we are giving supply to the stator, and output is your motion of the conductor. That is a rotor. Clear? So the function of commutator is for the rectification. Brushes are there, bearings are there. Fine. So brushes where commutator, because commutator is also a rotating part which is connected to the your armature. Clear? Now ये कंडक्टर उसके ऊपर जो होगा वो रोटेट होता है. फाइन. बट ये रोटेट होगा तो उसका जो टर्मिनल होता है वो क्या होगा? फिर वो टर्मिनल भी रोटेट होगा. बट वी वोंट द स्टेशनरी और फिक्स्ड टर्मिनल्स. सो ये जो शाफ्ट होता है, ये जो कम्यूटेटर होता है, तो कम्यूटेटर के ऊपर एक छोटा सा कार्बन ब्रश फिक्स किया जाता है, एक नीचे भी फिक्स किया जाता है ऐसे. एंड ये कार्बन फिक्स आर स्टेशनरी, will not rotate, but obviously there is a friction between this rotor and brushes which are mounted on it, and here from this brushes, by some arrangement, the rotating circuitry is being converted into a stationary circuit, and we can have a kind of electricity here. Right? So carbon brushes are used on this, like a kind of cycle where we have a carbon brush, brakes. Fine. So rubber material is there, which is having a friction with this circular cycle rotation, and hence, so similar kind of things is kept here with the help of spring that can be fixed with the on the surface of this rotor, and we can say commutator, and hence the electricity is. And we know that the function of bearing is employed for what purpose? For a roller bearings are preferable. Fine. So such kind of various bearings are used for rest of this whole rotor onto a shaft. Clear? So classification of DC generators. So DC generators are again classified based on the excitation system, that is a self-excited system. So here the symbol of diagram, suppose if it is a generator, so the symbol is looking like this, and this is a symbol of field winding. So field winding, this is the field winding, this one is the armature winding. Clear? So according to the connections of this field winding and armature winding, according to these connections, various generators are classified. Suppose if both these windings, field winding as well as this armature winding, both are excited separately, then it is known as separately excited generator. So this is a separately excited generator. So here the DC supply is given from some other way, and here also DC supply is given. So both these windings are separately excited. Now, in case of separately excited and self-excited, where self-excited in which both these windings, so this is your armature winding, and this is field winding. Suppose if both are connected in parallel, so this kind of generator is known as shunt generator. Clear? And if both these windings are connected in series, then it is known as series generator. So in series generator, this winding is connected in series. So this is series. This is AA armature and FFF. Clear? So this is a field winding and this is the armature winding. Both are connected in series. Then it is known as series generator. This is a series generator. Now, what is compound generator? Compound generator are made up of shunt and series both. Clear? So here, if we have a diagram, so part of that, this is FFF, this is AAA. So both the windings are connected in series, and again one more shunt field winding which is connected here, F dash F double dash. So this is a field winding connected in series with the armature winding, and this is again both these windings are connected in shunt with another winding, and such kind of an arrangement is known as compound generators. Getting my point? Any question? Okay, students. So we have one more lecture on Wednesday. Clear? Where I'm going to discuss about the various classification of various motors, and then a little bit introduction of AC motors. Clear? Now, first of all, I would like to ask you that I have sent you a mail yesterday in the evening to all the students, those who have not submitted some assignments. So it is my humble request, within a day or two, kindly submit it. Otherwise, I will keep 0 in that component, and then you will be bare the result at the end. So my humble request to all of you, please go through this, and those who have not submitted yet, if you have any difficulty for submission, let me know. We are going to help you in this case. Clear? Those who have received a mail yesterday in the evening, they understood it very well. So please do such kind of thing on time. Anything else you would like to ask? Because there are some constructions work is going on, it would be difficult for me to continue. So next Wednesday, which is the last lecture of the semester, where we are going to discuss about the classification of DC motors in detail. And I'll show you one video also. Fine. So do you have any question right now, or otherwise we can stop this lecture here? Any question? Anything else you would like to ask regarding your additional test?
No, sir.
Fine.